Welcome to Microsoft Build 2017. When something goes wrong with your code in production, what do you do to track down the problem? Do you stop the production system to install a debug build with extra printfs? Do you install a debugger on the production machine to step through the code? Of course not. What if there were a simple way to add tracing to your code with minimal impact on performance so that it could be used in production builds without causing problems? I'm Doug Cook, a developer on the instrumentation platform team at Microsoft. I'm going to show you how easy it is to add production tracing to your code using ETW, Event Tracing for Windows. Now, when I talk about production tracing, what do I mean? Well, tracing is simply getting information from your program to you. One common way to do this is with printf, or in .NET with console.writeline. And this works really well for console tools or during early development. It doesn't work quite so well for GUI apps, for web apps, or services or drivers. And it definitely doesn't work well for production or retail environments. Another common way to get information from your program would be output debug string, and this sends information to the debugger. Of course, this assumes that you've got a debugger attached, so it's great during development, but not so great during production. And it's especially bad for production because it has a performance impact and there's no filtering. If everybody used debug output string for their component apps in production, then your output debug string would be lost in the noise. One final way that people can use to get information out of their programs is log files, which again, they're great for low volume information that needs to be kept long term. They're great for information that might be of use to your customer, but they're really bad for detailed, high volume diagnostic information such as the stuff that you might want to know when you're diagnosing a problem. To fill in this gap, Microsoft invented ETW, Event Tracing for Windows. ETW has been around since Windows 2000, and it's just a technology that routes information from your program to an analysis tool. It's designed to work for production systems. It can send the data to a log file, to a memory buffer, or to a real-time consumer through callbacks. And it works for drivers, services, and applications. It even works for Windows Store applications. It's part of the Universal Windows Framework. Now, Windows itself uses ETW quite extensively. ETW is one of the first system services that starts up early during boot, so it can be used for boot tracing, and it's one of the last system services to shut down, so that it can be used for shutdown tracing. One of the big advantages of ETW is that it provides a separation of concerns between the event producer, your code, and the event consumer, whoever's collecting the trace. The event producer is responsible for producing good events, such that they answer a specific question and have the information needed to diagnose a problem. Also, the event producer is responsible for tagging the events with something like a severity level and event categories. The consumer, on the other hand, is the one that's responsible for where those events get stored, what maybe to a log file, and which events get stored, and when the trace starts and when the trace stops. That's something that the event consumer has to worry about, but your code doesn't worry about. And this separation of concerns is very powerful. Another important aspect of ETW is that it works for development, test, and production scenarios. Now, what makes ETW work for production scenarios is that tracing is disabled by default, and there's powerful filtering capabilities to turn it on only on an as-needed basis. When tracing is disabled, it has almost no impact on your code's performance. And when you enable the code to enable tracing, it's very, very low impact, less than a microsecond typically for most events. And even that, then it's non-blocking beyond that microsecond. A background thread is responsible for taking your events and flushing them to disk. One additional aspect of ETW that makes it work well in production is that it has powerful filtering that doesn't require you to reinstall your app, restart your app, or do anything else if you want to change the filter or enable a trace. So I'm going to show you very quickly how to enable ETW capture. So I have this demo app that I wrote that just writes a few ETW events. Now, it doesn't do anything now because I don't have anything attached. So what I'm going to do is I'm going to start a trace. And I'm going to use a tool that's built into the Windows driver kit, and called TraceView. And this version of TraceView has received some significant updates in the Windows 10 Creators Update, so be sure you're using the latest version. Start TraceView, And the most important thing you need to know to start a trace is you need to know the GUID under which the events are being written. In this case, I have kindly presented my GUID right in the front of the app, but you'll usually know the GUID that you used for your events. So let's try this again. All right, start the trace. In this case, I have the option of a real-time display or to log the event to trace file, or both. In this case, I'm just going to do a real-time display. So now I have a trace started, and I click a warning, and a few seconds later, a warning event shows up in my trace viewer. I click error, and a few seconds later, the error shows up. Now, this delay is only because ETW is performing batching to reduce the performance impact of this tracing on the system. Now, you'll notice that each one of these events comes automatically annotated with a provider name, the process ID, a thread ID, a physical CPU number, and a timestamp. We didn't have to do any of that ourselves. And it also comes with a message, information that was included in the trace. It has an event name. In this case, the event name is error button or warning button, a timestamp, a severity level. In this case, the error message has severity level 2, and the warning message has severity level 1, and a little bit of data that I included in the event. In this case, the data I included was the sender.toString of my WinForms app when in the event handler for writing the event. If I wanted to, right now I'm getting both warning and error messages. Let's say that the warning messages turned out to be too noisy and I wanted to turn them off. Well, without even restarting the trace or restarting my app, I can change the level on this. So now I no longer get warning events, but I do still get the error events. So that's the power of ETW and how easy it is to start an ETW trace. Let me close this down, the trace, and close my app. Now let me talk about a few of the scenarios where ETW works really well. Obviously, this could be used during the development process for debugging. For example, have you ever hit a COM reference count issue? Well, I've used ETW to track down some of these issues really effectively. One thing I can do is I could take a particular class and add an ETW trace statement to the addref and the release methods of that COM object. And then I could start a trace and reproduce the issue. Now, particularly interesting, ETW has the ability to capture a stack trace for each event. So in this case, I would maybe capture a trace with the stack traces enabled for the addref and the release events. Then I'd be able to start a trace, run through the repro, stop the trace, decode the trace, and at my leisure, figure out which line of code was doing an addref or a release that wasn't balanced by another corresponding addref or release. Another common scenario is what I talked about before, where you can use ETW for field diagnostics. If a customer complains about a problem, you can give your customer instructions on how to start a trace. The customer can then reproduce the issue, stop the trace, and send you the resulting log file. You can then, at your leisure, without interrupting the customer's production scenario, figure out what went wrong with your application. Now, in the scenarios I've talked about before, we've been using ETW to capture events from across the entire system. And this is the normal way that ETW works. It captures all of the events from the kernel, from the user mode, from other users on the same machine. But because this mode captures so much detailed information from across the system, it requires administrative privileges to run, which is why I had to start TraceView from an administrator prompt. However, ETW has a second mode of operation where it only collects information from the current process. And so you can use this mode for something like a flight recorder of your current process's behavior. You could create an in-memory buffer and collect detailed ETW events about your process's behavior into this circular buffer, such that the newest events overwrite the oldest events. Then if something bad happens, like an unexpected exception, or if your customer reports a bug, you can flush this buffer to disk and then include the resulting ETL file in your trace report. Finally, you could use ETW to help you implement a log file. Once again, you'd use a process private trace session and you'd collect the data into an ETL file. I'm going to show you really quick how easy it is to add ETW tracing to a C++ app. And in this case, I'm going to be using what's called the trace logging ETW framework. So I've got a little demo app that I've prepared. Now, this is just a very simple benchmark app. It's mainly made to show the performance characteristics of ETW, so it doesn't do very much interesting. At present, it has no tracing in it. It just starts a timer and then runs a subroutine. And this subroutine just runs through 1,000 iterations of interlocked increment. And this is just a simple application meant to show basically the performance of a for loop. So I go into the release directory and run my ETW-CPP application. And I can see that this app benchmarks at about 8.6 nanoseconds per iteration. So it can do 100 million iterations per second. Let's add ETW tracing to this. Now, we're going to use the trace logging ETW framework to do this. The first thing we have to do is we have to change our app to reference the Windows 10 SDK. Now, this doesn't mean our application requires Windows 10 to work. It just uses the new headers and libraries that are included in Windows 10. Now, let's say we want this application to continue to work all the way back to Vista. The ETW trace logging framework does support running on Vista or later, but by default, it takes advantage of Windows 8 APIs. So in order to make sure that our program will continue to run on Vista or later, we need to make sure that WinVer or Win32WinNT is set to Windows Vista. Once we've done that, we can safely use the trace logging provider header from the Windows 10 SDK and know that it won't introduce any compatibility problems with our app running on Vista or later. Now, if you go into this trace logging provider header, you can see that it's got a lot of comments, including a quick start. And we're going to do something basically the same as what the quick start shows. Then there's a bunch of additional documentation that you can investigate to learn more about trace logging. The main thing we need to do the first thing we need to do in our app is we need to declare a provider handle. Now, this is done with the trace logging define provider macro. Now, there's also the declare provider macro, which is used for forward declarations. In this case, we're just going to define the provider. Now, first thing it needs is a handle variable name. And we're going to name it mylogger or something. Then it wants a provider name. Now, provider names are global across the system, so they should probably have a namespace like Microsoft.etwdemo. And finally, it wants a provider ID, and this is a GUID. Now, when generating the GUID, we need to make sure that we understand that the provider name and the provider GUID are tightly coupled. Whenever we change the provider name, we also need to change the provider GUID and vice versa. To make this connection explicit, the ETW team is recommending that we generate the GUID not using GUIDgen, but that we generate the GUID as a hash of the provider name. And there's a tool on my blog, which I'll reference at the end of the presentation, that you can use to generate a GUID based on the provider name. The tool is named ETW GUID, and all I have to do is give it the name of the provider I want to use, Microsoft.etwdemo. And once I've done that, it provides me just a declaration that I can copy and paste directly into my app. Microsoft ETW demo. Now, the next thing we need to do is we need to register ETW. We'll register this handle with ETW at the beginning of the application. So if this were we're going to use the trace logging register method and just provide it the name of our provider variable. And at the end of the program, we need to do something similar. We need to unregister. So trace logging unregister. And provide the provider handle. If this were a DLL, you'd do this registration and unregistration in DLL main. And if this were a driver, you'd do the registration and unregistration in driver entry and driver unload. this code works basically the same in kernel mode and user mode and in drivers and in Windows apps. Finally, we get to the point where we actually create ETW events. For that, we use trace logging write. It wants the name of the provider, hmyprovider, and it wants an event name. In this case, we're going to use, say, run app counter inc. Okay. Next, we get to put whatever we want. And in this place, we can put variable names, fields that we want included in the event. Trace logging string. Let's put the string data variable. For a null terminated, it's a wide string, so we need to say trace logging wide string. For a null terminated string, and we'll give this field a name, string val. We also want an integer, trace logging int 32, put the counter, and give it a name, counter val. So this will create an event with 2 fields, and let's give it a level, a severity level. The severity levels go from 1 for critical error, 2 for error, 3 for warning. So let's give this the level of 4 for info. Trace logging level 4. Now that's all I need to do to add ETW to my application. Compile, succeeded, and now I can go to the command prompt and run my application again. And now you'll notice that this had almost no impact on the performance of my application. It was giving 8.6 before, and now it's giving 8.2. Hey, adding tracing made it faster. No, not really, but it didn't have any appreciable impact on the performance of my application. Now, let's start a trace that collects data from this application. This time, instead of using traceview, I'm going to use xperf and capture, which is a command line tool that lets me capture traces to disk. I need to start a trace, and I'll give the trace a name, trace. I want the trace to go to a file, trace1.etl, and I want the trace to take information from my app, but not from other applications. So I do on. Now, xperf in the new Windows Creators Update has a new ability to take the name of the trace instead of the GUID. Normally, I'd put a GUID here, but instead, if I put a star and then Microsoft.-etw demo, it'll use the same algorithm to produce the GUID as I used with my ETW GUID tool. Now I start the trace, and now let's run my demo again. This time it took a little bit longer, 494 nanoseconds per iteration. That's still less than half a microsecond, so we could get 2 million events per second out of our trace, but it did have a little bit more impact because we turned tracing on. Now we can stop the trace, xperf stop trace, and now we have a trace file with 1,000 events. Now there's various ways to decode this trace. For now, I'm going to use a tool called trace format. I could use traceview, but for a GUI decode of this file, but for now I'm going to use trace format. And trace format, display only, trace1.etl. And there we go, 1,000 events. Let's cut that off. But you can see for each one of those 1,000 events, it gave me the provider name, it gave me the event name, run app counter inc. It gave me a timestamp. It gave me the level for information, and it gave me the data, the two fields that we added to the event: string val, which had the name of the app, and counter val, which increments each time through the loop. 444, 443. Great. So that's how you capture a trace, and that's how you add instrumentation to C++ app using the trace logging framework. To review, adding tracing to a C++ app just requires that you use the Windows 10 SDK and you include traceloggingprovider.h. That header works in kernel mode and user mode, and it even works in Windows Store apps. Read the comments in the header for more information, and since Trace Logging Provider will by default take advantage of Windows 8 APIs, be sure to define a Win32 WinNT before including Windows.h if you want compatibility backwards to Vista or Windows 7. Next, you use trace logging define provider, and we recommend that instead of using a generated GUID, that you use a GUID that's based on the hash of your provider name using the ETW GUID tool that I have linked in my blog. Finally, at the beginning of your program, use trace logging register to initialize the provider handle, and trace logging unregister to uninitialize. And you don't need to do any error checking. If this fails, if trace logging register fails, all it means is tracing won't be enabled for your application. It won't cause any crashing. But you do need to always do trace logging unregister, especially for DLLs or drivers. Finally, in the places where you want to add instrumentation to your application, use trace logging right. I'm going to do a similar demo for how to do trace logging in a .NET application. And just like before, I have a .NET application that simply starts a stopwatch and then runs interlocked increment 1,000 times to show performance implications. If I run this or ETW.NET, we can see that it runs at about 10.6 nanoseconds per iteration, pretty close to the C++ version. Let's add some instrumentation to this application. The first thing we need to do is we need to set our framework version to .NET 4.6 or later. The APIs that I'll be showing in this demo were introduced in .NET 4.6. Now there is a NuGet version that you can use for earlier versions of .NET, but we recommend that you use the new APIs introduced in .NET 4.6. The APIs that I'm going to show also work in the portable class libraries and in the universal application framework. First, I'm going to add a new namespace using system.diagnostics.tracing. And then I need a global variable that has my logger. And what I typically do for this is a public static read-only variable attached to a good place for a global variable such as program, or if you've got a class named globals, that would work too. The type of the variable is event source. And I'll call it my logger equals new event source. And all we need here is a name. But once again, use Microsoft/ETW demo. And in this case, event source didn't even ask for a GUID. It's going to use that same algorithm for hashing our provider name to generate the provider GUID for our event source. The only thing we need to do now is add some events to our program. So let's do my logger.write, and it wants an event name. And then we could optionally provide options, event source options that include things like the event level and keywords and opcodes, which are advanced ETW topics. Let's just set the level equals event level.info, information, just like we did for the other demo. And finally, we need to provide some information to include in the event. So in this case, we're going to use the C# feature of anonymous objects. We're going to make one variable be the string val equals string data, and we'll have the counter val equals counter. That's all we need to do to add ETW to our application. This anonymous object will be turned into one field for each of the properties in it. I'll build this application and we'll run the ETW.NET. And notice that we do have a little bit of a performance impact from adding ETW, but it's still on the order of nanoseconds, not even microseconds of overhead added to our application. There are advanced ways that you could even reduce that further, but for now, I consider that to be pretty good. Now let's do the same thing as we did before. We'll start a trace, and this time it'll be trace2.etl. And we'll run our application, etw.net. And this time there's a little bit of overhead. It's now a few microseconds each time you write an event through the .NET framework, but it's still microseconds. It's still not a serious impact on your performance. Now we can stop the trace, and we have trace2.etl. Now, this trace is a little bit bigger, and that's just because we actually ran more iterations and there are more events included in the trace file. But they basically look identical to the ones that we produced in the C++ app. So let's go back to an overview. All you need to do to add trace logging ETW to your .NET application is set it to use .NET 4.6 or later, or the Universal Windows application framework. If you need compatibility with earlier versions of .NET, there's a NuGet package available for that. Define a global event source object and call the write method with an event name and an anonymous object with field names. The write method, if you're concerned about garbage collection, you can create structs as well. So that will reduce the amount of garbage generated during your .NET tracing. So getting started with ETW, let me just review. We've got provider libraries. If you're doing C or C++, use traceloggingprovider.h. If you're using .NET, use event source. And if you're using the Windows framework, there's a class that was updated for Windows 10 called logging channel. And then on the consumer side, there's a whole bunch of different tools, many of them that received significant updates in the Windows 10 Creators Edition SDK. And I'm not going to go over them all here, but there's a lot of tools available for ETW. One thing I want to mention is that I just mentioned that we would be using the ETW trace logging framework. What do I mean by an ETW framework? Well, a framework is a language for describing provider and event characteristics, and it's a tool that helps express the provider name, the event name, the severity level, and the field names for our events. Remember that back in the demo we added a couple of fields and we gave them a name using trace logging macros. The framework is what's responsible for taking those event field names and putting them into the event. The ETW framework typically involves some code generation to help filter out the events efficiently, and they also involve some code generation to help you pack your events. And finally, an ETW framework is something that supplies a method for getting the metadata from your program to the decoder tool, like xperf or trace format. Microsoft, just like in just about everything else Microsoft does, there's multiple ways to do it. And over the course of ETW history, there have been several ETW frameworks invented. One framework is based on WMI and MOF, and that's mostly obsolete, but I just mentioned it here so that you'd recognize it if you saw it again. Another framework is called WPP, and this is a fairly old framework, but it's still fairly popular because it allows you to author ETW events directly in your C or C++ source code using printf formatting. It uses PDBs for decoding the events. In Vista, we introduced a new kind of ETW based on XML manifests. And that way you author your ETW events inside a manifest, and you use the MC manifest compiler tool to generate the code for generating your events. Finally, in Windows 10, we introduced the trace logging framework, which is what I showed in the previous samples. And this gives structured events authored directly in your source code, similar to WPP, but the difference is that decoding always works. The trace logging framework puts the decoding information directly inside of each event. Now that has a consequence. Each event will be slightly larger because it has a few strings in it. On the other hand, it means that your events always decode. You don't need to look up a PDB or a manifest to decode your event. And that's why we really encourage people to try trace logging. It's a really easy way to get started with ETW that doesn't require any special tools and doesn't require tracking down a manifest or a PDB to decode your event. So I'm often asked which framework is best, and in a core embarrassing answer is that it always depends. Each of these three frameworks that are still supported is best in at least one scenario. I often draw this diagram with colored circles to show that there are some situations in which WP works best, there are some situations in which a manifest-based ETW works best, and there are some situations in which trace logging works best. And there are some situations in which any one of those three would work just fine. The answer is pick the one that works best. What are our recommendations? Well, if your event needs to work with event log, you pretty much have to use a manifest-based ETW solution. If your event doesn't need to work with event log, then you've got a few more avenues for flexibility. If log size is the most important concern for you, if you're generating gigabytes of logs, then you probably want to use manifest-based ETW because it generates small events. You might also consider WPP because it also generates smaller events. The trace logging framework, like I said, adds a few strings to each event, and that can make your logs bigger. But if the log file size is not your chief concern, if you're just dealing with a few hundred kilobytes of logs, then the event size isn't a major issue and trace logging might work better. Now, if you need to keep, some people want to keep their metadata private. They don't want customers to be able to decode the ETW events. And if that is your situation, then once again, you'll want to use manifest-based ETW or maybe consider WPP. And if you're happy with your existing framework, well, keep using it. There's no real reason to change. But for ease of development and to make sure that your logs are always easy to decode, we strongly recommend that you consider trace logging. All right, so in summary, ETW is really easy. It doesn't have to be complicated. Try out ETW. We've added these new headers and APIs in the Windows 10 SDK and in .NET 4.6. In Windows 10, there's also logging channel in the Windows framework. And we've updated the SDK tools for ETW in the Windows 10 Creators Update. All right, I've got a couple of resources I want to point you to. I've got a blog, and I have an ETW overview and trace logging background, tracing tools, and you're welcome to revisit the Channel 9 recordings for build. So thank you very much for listening, and good luck with ETW.